All right, so let's take a look and see how do we know if something's divisible by 6. Yesterday we did a whole bunch of these. We did how do we know if it's divisible by 2, 3, 4, and 5. Today though I'm throwing 6 at you. So how can we know? Well, the trick to being able to figure out if something's divisible by 6 is knowing that 6 is just 2 times 3. So in order for it to be divisible by 6, it has to be divisible by 2 and by 3. So basically what I need to do is I need to see if any given number meets both of those requirements. So let's start by going through and eliminating anything that's not divisible by 2. 54, is that divisible by 2? Yes. 21? No. Okay, so I know that one's out. 44?
Yes.
Yep. 87?
No.
Nope. 108?
Yes.
Yep. And so remember that the way we know is that if it's even, it's divisible by 2. If it's odd, then it's not. So I just got rid of everything that was odd, because if it's odd, it's not divisible by 6. Now I need to look at the remaining ones and figure out, can I divide it by 3? Now remember the trick for knowing if we can divide it by 3? We can add the digits together. So like for 54, what's 5 plus 4? 9. Is that divisible by 3? Yes. Therefore 54 is divisible by 3. Since it's divisible by both 2 and 3, it is divisible by 6. Now, one of the great applications for this sort of thing is it can help you when you're doing your factoring and stuff like that too, because you'll know which numbers could possibly go into it. All right, let's keep going through these. 44, is it divisible by 3? Well, 4 plus 4 is 8. 8 is not divisible by 3, so no. 108, is it divisible by 3? Well, what's 1 plus 0 plus 8? That's 9. Is 9 divisible by 3? Yes, so that one is divisible by 6. 182, is that divisible by 6?
No, because it equals 11.
Yep, it equals 11, so the answer is no. Great. 996?
Yes.
Yes, it is. 1028? Nope. 5234? Nope, because 5 plus 2 is 7, plus 3 is 10, plus 4 is 14, which is not divisible by 3.
12.
And finally, 9,474?
Yes.
Well, what's 9 plus 4? 13.
Yes.
Plus 7?
Yes.
20. Plus 4 is 24. Is 24 divisible by 3?
Yes.
Yes, it is. And so, since it's even and divisible by 3, it is divisible by 6. Next up, we're going to practice our evaluating function, so I'd like you please to write down and evaluate each of these two. All right, so for that first one, the first step I want to see on your paper is where you just plug in the -2 for the x. Everywhere where there was an x, there's now a -2. Now a little note on that. Because this is minus a -2 here, I am putting parentheses around my -2 just so that I don't see too many random little marks strayed within there. All right, now we do have minus a -2 though. How do we do minus a negative? Minus normally means to go down the number line, but negative means flip it around the other way, so it does mean it's the same as adding. So it's the same as adding a positive. Think those two minuses combine and become that plus sign. All right, now I'm still going through my order of operations, which means doing the stuff that's inside the parentheses, in this case the absolute value brackets, first. And then what is the absolute value of 6? 6. Because remember, absolute value makes it positive, or in this case, leaves it positive. Now notice though that it gave me a -6. That's because that negative that was outside of the absolute value is being attached after we take the absolute value inside, because the negative is on the outside of the absolute value. So now I have -6 plus 8. Then that's just adding with the positives and the negatives. So I start down at -6 on my number line. And then I'm going to the right 8. That is enough to cross 0, so I'm definitely into the positives here. It's +2 to be more precise. Now for the second one, we're finding f of 6. So again, first step, I want to plug the 6 in for x wherever it appears. Notice in this case, that means it, of course, goes in the notation right here, but it also goes in for both of the x's that are in our equation on the right side. Now a little note here. Notice we have negative 6 squared. When we have that negative 6 squared, I do not want parentheses around the negative 6. I don't want it to look like that. If you did want to include parentheses, you can, but it would only be around the 6, not with the negative, because the negative is sitting in front of the x squared. I'm going to have to square it before applying the negative. So let's go ahead and do that now. 6 squared, that gives me 36. So it's a negative 36. And then negative 36 plus 30, again, you can think about that number line. We're starting way down at negative 36, and we're going up 30. Is that enough to cross 0? No, so we're still in the negatives. Negative 6 to be precise. All right, so we're going to be seeing how we can go about solving this word problem. So we got some caterpillar climbing a tree, and we have some distances that we're working with here. Now, for some of us, we're going to be able to look at this and instantly be able to turn it into numbers and equations and ways of looking at it that way. But I certainly don't expect that's going to be true for everybody. I wouldn't necessarily want it to be true for everybody. So how do we go about solving this? The first thing I always suggest doing with a picture as you're trying to kind of digest what you're doing is to actually draw out that picture. So here I have my tree. And somewhere up on that tree, we have a caterpillar that's 4 feet up. Okay, so that caterpillar is 4 feet up the tree. Now let's start figuring out how high it's going from there. He's climbing at 6 inches each minute. How high is he going to be after 1 minute then? Well, it's got to be 6 inches higher, but what's 6 inches higher than 4 feet? We're talking different units. That could make things tricky, right?
It's 4 feet 6 inches.
So, how much of a foot is 6 inches?
How much of a foot is 6 inches? That's half a foot.
Yep. 6 inches is half of a foot because there's 12 inches in a foot. So rather than thinking of this as, okay, I'm going up by 6 inches, I'm going up by half a foot. So after 1 minute then, he would be at 4.5 feet. After 2 minutes, that'd be 5 feet, and so on. So the question is, how high will a caterpillar be in half an hour? Well, we know how much he's going up each minute, not each hour. So half an hour, how many minutes is that? Half an hour is 30 minutes. Because there's 60 minutes in an hour. So half of the 60. So that means I'm climbing half of a foot each minute for 30 minutes. What should I do with the 1/2 and the 30 then? Multiply them. Because what we're doing is we're traveling at half a foot per minute. Anytime you see per, that tells you to multiply. So 1/2 times 30. What's half of 30? 15. And that's how you can multiply something by 1/2, is it's half of it. You're just cutting it into 2 pieces. So that means he's going to climb 15 feet.
That's a fast caterpillar.
Well, it took him half an hour to get there. So if he climbed 15 feet, what's our answer? 19. Yeah. Because we started at 4 feet. And then we climbed 15 feet. So that's why he's going to be a grand total of 19 feet up our tree. So in this problem, we got 4 people that are going up Mount Pilchuck. They got 15 quarts of water between them, and they want to share that evenly. So we got to figure out how much each person gets. And again, how you approach it could actually vary from person to person. Some people will look at it instantly and break it down to some numbers. Others, if you don't see how to do that right away, go ahead and draw a picture. So I'm going to start by doing this visually, and then we'll take a look and see how we could have done the same thing with the numbers, just to look at both different ways. So to start with, I got my 4 little people here. And with those 4 people, I need to divide up the 15 quarts of water. So each person gets 1 here. Okay, so that's 4 of them. Okay, let's break them up again.
15's an odd number.
Now I've taken care of 8 of them. Okay, let's go more. Now each person has 3 quarts of water. How many quarts of water have I represented total? 12. So I don't have enough to give everybody still 1 more. Because I got these 3 bottles, or these 3 quarts of water left over here. So how do I divide those 3 quarts of water amongst 4 people? How much would each person get? Well, aren't you really taking 3 and dividing it amongst 4? What's 3 divided by 4? Well, the easiest way to write it would be 3/4. So really, each person gets 3 3/4 of a quart of water then. And so we take whatever is left and we can just turn that into a fraction. So since there was 3 quarts left, we're dividing it amongst 4 people. That's why it's 3/4. Now the symbolic way of doing that same thing is that we could have taken our 15 quarts of water that we started with and divided it by the 4 people that we were splitting it between. So if you're thinking more symbolically, more numerically, this is the way you would have written out the problem. So we do 15 divided by 4. So in order to do that division, we say how many times does 4 go into 15? How many whole times does it go into 15? Well, it goes in 3 whole times, because 3 times 4 gives us 12. Now, when I do that, that brings me up to 12. So how many are left over still out of my 15? 3. And so 3 3/4. So it can get us to that same place. It's just taking a different tactic. And again, one is not inherently better than the other. They're just different tactics, and you find the one that makes sense the most for you.